Lesson 8.3, dealing with our third conic section. In this section, we're going to be discussing hyperbolas. The basic definition for a hyperbola is a set of all points in a plane whose distances from two fixed points in the plane have a constant difference. Just like the last two sections, we have a table that organizes our information. Very similar stuff, except when we get down here, before we had the semi-major axis and the semi-minor axis. Now we have the semi-transverse axis and the semi-conjugate axis. Very similar. A is going to refer to the larger of the two values between A and B. The semi-transverse axis is basically going to be half the length between the two vertices of the hyperbola. Also notice that our Pythagorean relation is now in the form that we're more familiar with. C squared is equal to A squared plus B squared. First example, we want to find the vertices and foci of the hyperbola 9x squared minus 4y squared equal to 36. Just like the previous lessons, the first thing we need to do is divide by 36 so that we're equal to a value of 1. Thus we get x squared over 4 minus y squared over 9 equal to 1. Rewrite the denominators as perfect squares or some number squared. So we get x squared over 2 squared minus y squared over 3 squared equal to 1. The difference between writing hyperbolas versus parabolas or ellipses is that since we're subtracting, now we want to make sure that our positive term comes first. We're not going to write whichever term has the larger value in the denominator first. Since we're subtracting, the order matters. So now we have to put our x squared term first because we're subtracting the y squared term from that. So our value of a is going to be the denominator of whatever term comes first. So our value of a in this case is going to be 2, and our value of b in this case is going to be 3. To find the value of c, we have to use the Pythagorean relation. So we have c squared equals 2 squared plus 3 squared, so we know c is equal to plus or minus radical 13. The values of a, b, and c are referring to distances, so we're taking that positive value. Now we know the value of a, b, and c, so we can identify the vertices and the foci. The foci are going to be at negative radical 13, 0, and radical 13, 0. The vertices are going to be at negative 2, 0, and 2, 0. Now to the next example, we want to find an equation of the hyperbola with foci 0, 4, and 0, negative 4, whose conjugate axis has length 2. So because we know the foci are at 0, 4, and 0, negative 4, we can determine that our value of c is equal to 4. And if our conjugate axis has length 2, the semi-conjugate axis is going to be half of that, and that refers to our value of b. So our b value is going to be 1. Now we use that Pythagorean relation to find the value of a. So a squared is equal to c squared minus b squared. Simplifying that, we get a equal to plus or minus radical 15. We're talking about distance, so we take the positive value. Now we know c, b, and a. Now we have enough information, we should be able to write the equation for this hyperbola. Since we know the x-coordinate of the foci is 0, and it was the y value that was changing, we had plus or minus 4, we know our y squared term is going to come first in our equation. So then we end up with y squared over 15 minus x squared over 1 equal to 1. Now we're going to discuss hyperbolas that are not centered at the origin, just like we did with parabolas and ellipses. So I would organize this information in a table so that you can quickly refer to it. Next example, find the standard form of the equation for the hyperbola whose conjugate axis has endpoints negative 1, 4 and 5, 4, and where the transverse axis has length 8. So off to the right, now we have a sketch that shows the information we have. We have our conjugate axis endpoints, and we know the length of our transverse axis is 8. The conjugate axis is always going to be perpendicular to the transverse axis. Remember, the transverse axis is going to connect our two vertices of the hyperbola. So with this information, now we can determine the semi-conjugate axis, which is going to be our value of b, which goes from the center to one of these two endpoints for our conjugate axis. And then we also know the length of the semi-transverse axis, which is going to go from the center to one of our vertices. So we know the value of a, we know the value of b, and we also know where the center of this hyperbola is going to be, because it has to be the midpoint of these two conjugate axis endpoints. So now we write down the information we know. A is 4, B is 3. Our center is at the ordered pair 2, 4. Now we have to determine, is our x value going to come first, our x term, when we write the equation, or our y term? So if we look, our transverse axis is lined up along the y-axis. Okay, so our y term is going to come first in our equation. Our value of a corresponds to our y term, our y variable. Thus, our final equation is y minus 4 quantity squared over 16 minus x minus 2 quantity squared over 9 equal to 1. Now to the final example. We want to find the center, vertices, and foci of the hyperbola with the equation x plus 1 quantity squared over 4 minus y squared over 9 equal to 1. From that equation, there's a few things we can identify. We know the center of this hyperbola is going to be at the ordered pair negative 1, 0. Our value of a is going to be 2, and the value of b is going to be 3. So now we can use the Pythagorean relation to find the value of c. Setting up our equation, we have c squared equal to 4 plus 9. Simplify to get c equals plus or minus radical 13. This is a distance. We take the positive value. So now we know the values of a, b, and c. We know the values of h and k. So we can recall our formulas for the vertices and the foci, plug in the information we have to determine those ordered pairs. Thus, we can determine that the vertices are going to be at the ordered pairs negative 3, 0 and 1, 0, and the foci are going to be at the ordered pairs negative 1 minus radical 13, 0, and negative 1 plus radical 13, 0. The last thing to discuss in this lesson is the eccentricity of a hyperbola. So if you just want to write down the formula, E is equal to C over A. Okay, if we have time, we'll discuss what the eccentricity is referring to when talking about these conics.